All right, you guys, we have section 4.3 today, graphs of secant and cosecant. We're going to do first. And just remember those reciprocal pairs that we've been talking about this whole year so far. Remember how sine goes with cosecant? So the cosecant graph is very, very similar to the sine graph. There is one major change, but we're going to start doing the graph the exact same way we've done the sine graph. The secant graph is very, very similar to cosine. What you can see here is that this is my normal sine wave, and the period is 0 to 2 pi, so this is actually 2 periods of the sine wave. And this doesn't have a phase shift or a vertical shift or a period change or anything like that. It's just regular old sine x, the very first graph that we did at the very first page of your packet. And what I want you to remember here is that sine of 0 is 0. That's why that very first point on this sine curve was 0. That's the first of the 5 special numbers you guys have memorized. So remember how since sine of 0 is 0, when you flip that and do the reciprocal r over y, that makes cosecant of 0 undefined. Do you remember the word asymptote from Algebra 2? It's a dotted line that happens here. And also same exact thing for pi. Did you know that sine of pi was undefined? Or sine of pi is 0, excuse me. That is why the cosecant of pi is undefined. There's an asymptote there. Same thing with 2 pi. Sine of 2 pi is 0, therefore when you flip it, the cosecant of 2 pi is undefined. Those are all unit circle things that we've been quizzing you on day after day also. And same thing over here with the cosine graph. Since cosine of pi over 2 is 0, that means when you flip that fraction to do secant, you get an undefined asymptote right here at pi over 2. So just keep stuff like that in mind. This is all unit circle stuff, which is why it is crucial that you keep refining those skills on unit circles so that you understand all of these graphs that we're doing this chapter. So remember the reciprocal pairs, you have those written down on your unit circle. So that's where these are going to come into play here. I have a couple of things for you to copy down regarding the notes, and then I'm just going to do 2 graphs as examples, and then we'll talk a lot more in class tomorrow. So very first thing that you're going to do when you're graphing, this first one is a secant graph, so remember that goes with cosine, is we're going to pretend like this says cosine right here, and I'm going to put the 5 dots on my graph exactly the same way I would graph this if that was cosine. Remember, cosine and secant are the reciprocal properties. So the very first thing I'm going to do is identify this is the amplitude. That means that it is extra humpy by a factor of 2. This 1/2 is my b value. That changes my period. This is all review from the very first section. So remember, you do 2 pi over b, and b is 1/2. When you flip and multiply that, you get 4 pi. The period is 4 pi. That means that the length of distance it's going to take for me to get my 5 dots in is going to be 4 pi from start to finish. That means each tick mark, when I do my scale on my x-axis, is always the period divided by 4, since there are 4 gaps in between my 5 dots, is just going to be worth pi. And there isn't a phase shift, so there's no plus or minus anything in here with the x, so I'm going to start my graph right here at 0. So remember how if there's a phase shift, you move it to the right a certain amount or to the left a certain amount if there's a phase shift? There is no phase shift in this example. There's also no vertical shift up or down. But that means that my very first dot is going to go right here at 0. And then remember, each tick mark is worth pi units. So my first tick mark here is pi, then it's 2 pi, then it's 3 pi, and then 4 pi. And yes, double check from start to finish is the period, which is 4 pi. Okay, so let's talk about where the dots go. So I have my x-axis labeled, but remember how secant goes with cosine? So that means what I need to do is remember what my y values are for cosine. Y values for cosine. The cosine of 0 is 1, 0, -1, 0, 1. And what I need to do is modify this by multiplying by 2. Remember, the amplitude here is 2. That makes my graph humpy by a factor of 2. So I'm putting a 2 in front here, and I'm going to multiply all my y values by 2. So now what I'm going to do, just like we've been doing for a regular old cosine graph, I'm going to put my dots on the graph. I need to label my y-axis. So this is going to be +2, and this is going to be -2. My first dot here at 0, remember I'm starting at 0 for this one because there is no phase shift. for me to start at a different point. So I'm starting at 0, and my first dot is 0, comma, the y value is 2. So right up here. My next dot is 0. Next dot is -2. So far it looks exactly like what we've been doing in class. So what is the difference? What's the big deal, Mrs. Johnson? Get to the point. Let's follow where my steps are. So up here I said, number 1, sketch the graph of sine of x or cosine of x. This one we did cosine because it's secant. But don't connect them. So I'm not going to actually make my curve here like I usually do. That's because this is a secant graph. Step 2 says put vertical asymptotes at the zeros. So see how this dot is on 0 and this dot is on 0? I am going to actually put an asymptote there. And the reason for that is because when I flip 0, I get something that is undefined. So here's where the asymptotes come into play. And number 3 up here says use the other dots for U-shaped branches. And so if you flip back a page to look at what secant and cosecant graphs look like, they look like little parabolas here. This one goes down, this one goes up, and this one goes up. And it just continues in that pattern. So this is one period of the secant graph, but you guys know that the periods can continue on and on and on forever. But one period has to do with 5 dots, 1, 2, 3, 4, 5. And that is what my U-shaped branches look like. And then if you remember back to Algebra 2, whenever we had graphs that had asymptotes, they worked kind of like a magnet. And your graph actually approaches the asymptote. So it gets really close to it and runs up alongside next to it, but doesn't go through it. And so that forms the U-shapes. Okay, so it's really, really similar, you guys, to graphing sine and cosine, except you don't connect your dots like usual. You actually do the opposite of that. You like kind of flip it inside out, if you will. You put asymptotes where the zeros are, and then the other dots are used to form parabolas. Your parabolas, there should be a large gap in between here. That's how I knew not to make my parabola positive looking and this one negative, because there is supposed to be a big gap here in the middle. So make sure you point your parabolas in the right way. Let's do one more graph together. This one is a cosecant graph, so a couple important things about this one. I'm going to be graphing the 5 dots for sine, because sine and cosecant go together. This means that the amplitude is 3 over 2, so that means my humpiness is changed by a factor of 3 over 2. There's just a 1 here in front of this x. That means that the period is just normal 2 pi, so that's good. It's 2 pi over 1, whatever this coefficient is of the x value, and that doesn't do anything. But that means that each tick mark is 2 pi divided by 4, because there are 4 gaps, and that means pi over 2 is what each tick mark is going to be worth. Here we have a phase shift. This means right pi over 2, so that means my very first tick mark is not going to be on 0, it's going to be on pi over 2. So I'm shifting my graph to the right a little bit. Pi over 2 is where I'm going to start, so make sure you make a note that I'm not going to put my first dot on 0, I'm starting it here at pi over 2. So I need 4 other tick marks for my 4 other dots. Here they are, and I like to spread them out just so I have room to work and sketch and whatever. But remember, each tick mark is worth pi over 2 units, so I'm just adding pi over 2 each time to get all my other x values. Pi over 2 plus pi over 2 is 2 pi over 2. Yes, that's regular pi. Reduce it if you want to, or you don't have to. I'm going to add pi over 2 again, which gets me to 3 pi over 2. Add again, that's 4 pi over 2. Yes, that reduces. Don't care if you want to reduce it or not. And 5 pi over 2. So those are my 5 x values that are going to connect my 5 dots for the graph that I'm about to do. Notice that the period here is 2 pi. That means from start to finish, the distance between the start and the finish is 2 pi. When you subtract 5 pi over 2 minus pi over 2, you get 4 pi over 2, which is the same exact thing as 2 pi. That's just a way to kind of double check your work to make sure that you haven't added or subtracted any of your fractions wrong. Make sure that the period actually matches up with what you have on your x-axis. So where do I put my dots? I'm looking at cosecant here, which goes with sine. And so in that case, the y values for sine are 0, 1, 0, -1, 0. Those are the 5 quadrantal angles from the unit circle for sine. And again, I'm using sine because this is cosecant, those are reciprocals, I do need to do this amplitude multiplication thing. So it's a humpiness by a factor of 3 over 2. And so I'm going to put 3 over 2 here and multiply. Gives me 0, 3 over 2, 0, negative 3 over 2, and 0. So all I need to do is label my y-axis. 3 over 2 is between 1 and 2. And so remember, my first dot doesn't go on 0. It's going to go lined up with pi over 2. So my first y value is pi over 2, comma 0. So I'm going to put a dot there. My next one is 2 pi over 2, which is just pi, comma 3 over 2, which is the same as 1.5. So I'm going to fill in my 5 dots exactly the same way that I did for sine on the last couple sections. But remember, I don't connect them here. So look back up at your steps here. Don't connect them, but where the zeros are, so this one, and this one, those get asymptotes. So I'm going to put an asymptote here because when you flip 0, you get something that's undefined. And this breaks up my parabolas for me. And then the other two, how do I face my parabolas? There's supposed to be a big gap here in the middle. So this parabola needs to go up, and this parabola needs to go down. There's supposed to be a gap here in the middle. And so this parabola looks like this. It's going to approach the asymptotes but not cross them. They work kind of like a magnet, and they attract the graph to them. And that is what the cosecant graph looks like. So thank you guys for watching. Hopefully that doesn't seem too difficult since it's so similar to sine and cosine, but we're going to practice in class tomorrow, and I'll be able to answer whatever questions you got, okay? Thank you guys, and have a great night.